The overall goal of this experimental procedure is to grow single crystalline bismuth nanowires in a scalable manner through thermal evaporation in a high vacuum.
This method can be used to synthesize high-quality bismuth nanowires in high yields. The material has been of great interest in the field of thermoelectricity studies. The main advantage of this technique is that it involves no catalysts or seeds, and that the synthetic procedure is taking place in high vacuum so that the nanowires being formed is of high purity.
This method provides insight into how nanoscale porosity induces spontaneous bismuth nanowire growth, but it should also be applicable to other systems with low melting point, such as indium and tin.
To begin, vent the deposition chamber to atmospheric pressure and open the chamber. The venting is done by pressing the Start PC Venting button on the control software interface, which automatically starts a sequence that vents the chamber to atmospheric pressure. On reaching the atmospheric pressure, open the chamber by pulling the front accessing door. Then, mount a tungsten evaporation boat between a pair of thermal evaporation electrodes. Place 1 gram of bismuth pellets into the evaporation boat. Mount a vanadium sputtering target to the magnetron sputtering source. Next, connect the mini banana connectors of the closed-loop temperature controller to the electrical feed-through of the deposition system. To clean the growth substrates by oxygen plasma, place the growth substrates into a plasma cleaner and pump the chamber by pressing on the vacuum.